We are going to be looking at some questions. This question has to do with molar volume and Avogadro's number. So now, before we go into these calculations we have here, I want us to quickly look at some of the relationship between the Avogadro's number, molar volume, and number of moles, as well as mass. Now, assuming that we have the mass to be at the center, and then is equal to what? This 1 mole of any substance is equal to what? 22.4 dm cube, which is we know as what? Molar volume. That is if it's a gas. If it's a gas in this area. So now the same 1 mole is also equal to what? Molar mass, if we are considering it in grams. So the same 1 mole is also equal to what? Avogadro's number of particle, which is about 6.02 times 10 raised to the power 23. So that is it. So if you look at it now, if 1 mole is equal to this and 1 mole is equal to molar mass, then you can also compare these two to get whatever you want in number of particles and then compare with molar mass. Now, if this is so, it also means that you can also compare these two. Compare number of particles and molar volume to get what you want, depending on where you're coming from. Whether you want to get volume from number of particles, or you want to get from volume to what, or maybe from number of particles to volume. Now, the same way, molar mass has a relationship. This looks like more like a triangle. So this is some of the things you need to understand while we work on this, and we are going to be applying it in different ways. And the most exciting thing about this problem is that the last question here, which is number 3, is a mind-blowing question that will help you apply at least after solving that problem. After understanding, once I solve it, and I hope you understand it very well. Once you grab that question, you won't have any problem that has to do with this anymore. So let's quickly look at the first question that we have. The first question said, calculate the volume of a gas produced at STP if 5 grams of sodium reacts with excess water. Now, for us to do this effectively, for us to solve it perfectly, we need to do what? First thing we're going to do is to do what? Write a balanced chemical equation, because it has to do with stoichiometry. So we have water, and then if water combine with all sodium, we will get sodium hydroxide plus hydrogen. So the possible gas in question, the gas is not mentioned here. Then the possible gas there should be what? Hydrogen. So based on that, we need to balance this chemical equation. Put 1 here, 2 here, and put 2 here. I think we're getting it here. We'll put another 2 here. So I think it's balanced at this moment. This is gas, this is what? Aqueous, and this is liquid, and this is also solid. This is solid. So looking at this, you compare the relationship that is this here. What is simply telling us here, if you, from this balanced chemical equation, note very well, it said that it means that 2 moles of this sodium will give us what? 1 mole of 1 mole of hydrogen from the balanced chemical equation. Now, because we are looking at it at STP, now it means that at STP, we are looking at the mass. The mass is given to us. It means that from this balanced equation, it means that sodium is, remember that sodium is 23. 2 times 23 of sodium will give us 22.4 dm cube of the gas, which is hydrogen. So if we multiply this through, we have 46 grams. 46 grams will give us 22.4 dm cube. So now what will 5 grams give us? 5 grams will then be 22.4 all over 46 times 5 over 1. So when we do this, let's see what we are likely to get. When we do this, what we will get will be 22.4 times 5 divided by 46. The volume we have here will be, our volume is 2.43, let's say 5 dm cube. That is what we have. You can see how easy the problem is to get here. So remember, what I want you to point out here, is that you need to understand the information you have in a balanced chemical equation. From the balanced chemical equation, you compare the ratio to get what you want. So let's go over to the next question that we had. The next question says that how many atoms are there in 10 grams of calcium trioxocarbonate 4. So now from this one, just like the one we solved now, what we did now is from this mass to this volume. If you pay attention very well, mass to this volume. Now what we are going to solve now, the one we are solving next now is talking about mass. What we are doing now is mass, the mass again to what? We are moving from mass to what? This other one, Avogadro's number. So what we're going to do, let's quickly do that right away. We say that how many atoms? Now what do we know? That's already existing information you should note. In calcium, the molar mass of calcium is what? 100. Now I want to show you how I arrive at this mole per dm cube. Now calcium, let's quickly solve the problem. Calcium is what? 40. We add 40. Carbon is what? 12 plus 12. Then 16. Sodium is hydrogen. What am I saying? Oxygen is 16. 16 times what? 3. So if we add up everything we have here, we have here very well, we will have plus 40. We will have 100. That will give us the 100 in question. 100 gram per mole. So that is the molar mass. Now this molar mass can also, it means that a gram in 1 mole we have what? 100 grams of what? Calcium trioxocarbonate. So that means from the balanced chemical equation, from this relationship we have, not just balanced chemical equation, it means that you will know that 1 mole of this is equal to that, and 1 mole of the any substance is also equal to 1 molar mass. So that means if so, what we have is 100 grams. 100 grams. 100 grams of calcium trioxocarbonate is equal to what? We have contain what? This number of what? Atoms, because we are looking for the atoms now. So this is what we have. So what will this 10 gram have contain? 10 grams of calcium trioxocarbonate will then be times 23 over what? 100 multiplied by 10. So what do we have? We are going to, let me quickly rush it. We have 6.2 times 10 is equal to this, divide by 10. So what it will contain will be 6.02 times 10 raised to the power 22 atoms. Since we are talking of atoms, that's atoms that we have. Alright, you can see how we move now. What we have moved is from mass to what? Avogadro's number, and we arrive at this. So the last one, like I told you, I want you to pay attention as I solve this very last question. And if you are joining us for the first time, I want to encourage you to what? Subscribe to our channel. And don't forget, don't just go away without leaving down your question or leaving a comment. And then, so that if you have a question, just leave it there, leave it in the comment section. We'll always attend to you. So the next one we're going to do now, the last one, the bomb, the meat of the matter. That's what we're going to look at here. This question says that a vessel holds 10 grams of carbon 4 oxide gas. Calculate the mole of the gas in the vessel. Now, if you are looking at it for the mole of the gas in the vessel, now the first thing we do, we need to find the mass of molar mass. You know that mole is equal to mass over what? Molar mass. That is what it is. And we have the mass. Our mass is what? Our mass is equal to 10 grams. And our molar mass, we can always get this thing. Molar mass is what? We have carbon to be what? 12. Then oxygen. Oxygen is 16. Oxygen is 16. What do we have there now? 2 bracket 16. So when we do this, we can get, I think it's 2, then we have 12. What are we? Then we have 18. Yeah, well, I'm there. This is what we have. So we have 44. So what it simply means here now, since we have this volume, we can use this formula to get it done. Then the mole is equal to mass, which is 10 all over what? Molar mass. What do we have? We'll have, let's just rush it, 10 divided by 4. We have, what we have is 0.22227 moles. This is where our solution starts. The solution starts from here. We have this. The next question said the number of moles, molecules in the gas in the vessel. The number of molecules. Now we know that 1 mole from, I've cleaned it. 1 mole contain what? 6.02 times 10 raised to the power 23. Then 0.227 mole would then be 6.02 times 10 raised to the power 23 all over 1 multiplied by 0.227. So when we do that, multiply by, so what we get is 1.368 times 10 raised to the power 23. That's for the number of what? Molecules. Number of molecules. Now the last one says calculate that the volume of the gas at STP. At STP, 1 mole of every gas at STP, 1 mole of every gas contains 22.4 dm³. Then this mole that we have will then be at STP 0.7 will then be 2.4 over 1 multiplied by 0.227. So what we get here will be, 0.227 times 22.4. So we have, what we have is what? Let me do it again. Alright, it's like times 7. What we have is what? 5.08 dm³. Let's leave it like that. So this is the final answer. Thank you so much for being part of the class. If you are able to get to this point, I know that you are, I can say that you are amazing. Thank you so much for being part of this class. And if you have any question, leave it in the comment section. We'll always attend to you. And